Hello and welcome dear everyone. I hope you're doing well and great. In today's topic we are going to talk about NAT. NAT is a very important topic in the CCNA exams and it is used almost everywhere in our home networks, in our company's networks, and it translates our private IP addresses into the public IP addresses. So basically I'm going to talk about three types of NAT. Let me write it in here. Number one, static NAT. Number two, bad. And number three, we will work on dynamic NAT. Okay, let me just stop the recording and draw a very basic topology in order to work the NAT on it, and later on we will configure it together. So welcome back dears, we have done nothing here but a few drag and drops. I have dragged routers in here, two switches and few end devices. So this side would be basically my own private network, and this side would be my internet, the outside, the global side. So let me just also write the IPs on different scenarios in here, and for that I will stop the video again. I will come back later on. Welcome back dears. I have written the IP addresses of each devices in here. So the IP address for this device I will be using 192.168.0.2.0.3 for this one. So this is my network 192.168.0.0. Let me also write the network in here, which will be 172.16.0.0. Okay, so for this side of the network, which is inside local, I will use this IP address. So this is basically internet side. This is not our side. This is our side. So the term inside means the network that belongs to us. The outside, the network that doesn't belong to us. So the inside local, the inside network that we would use local IP addresses or the private IP addresses. So the inside global, the inside that we will use this one, the public IP address, in order to route it publicly, in order to route it over the internet. So the outside global means also outside of our network, but global side. And outside of our network, their local side or their private side. See, this is a private IP address, and this is also a private IP address. But this 12 is not a private IP address. This is a public IP address. Let me write it in here. Public IP. So let me also write it in here. This one is also a public IP. Okay, dear. So we will configure each devices one by one. Starting from this router, we will configure the router. We will also configure an OSPF in here, a routing protocol, and later on we will configure the three different types of NAT. So let me start from this router and quickly go through it. So first of all, let's go to this port. And give it the IP address 192.168.0.1, 255.255.255.0, the default subnet mask, and no shutdown. Let's go to the other port, which is 01. And let's give it the IP address 12.0.0.12, default subnet mask. Okay, no shutdown is already written, so let's write it. We will later on come back for the NAT, so for the moment it's enough for this router. Let's come to this router and do the same for this one also. Let's come to this G00 interface geek 0/0. IP address for this one is a public IP address of 12.0.0.13 with the default subnet mask. No shutdown. Let's come to the geek01. So interface geek01. This one, our outside local interface. So IP address of this one is a private IP address. It's obviously that when we are talking about the local sites, so we are using private IP addresses. This is why NAT came to existence, to serve to save the IPv4 addresses. So because of NAT, we can use private IP addresses on our private networks. If NAT were not there, so our private IP addresses wouldn't be translated to public and we would not be routed over the internet. So thanks to NAT. .16.0.1 255.255.0.0. Okay, this one is done with no shutdown. Let's save it. Okay. We are done with our routers for the moment. We will come back for the OSPF and the NATs later on. Let's go to the devices. 192.168.0.2 192.168.0.1. Let's copy this one, so we'll use it for the other PC also. One 192.168.0.3. Okay, it is done, and these two pieces should be able to ping each other without any protocol or without any routing protocol or NAT, because they are connected with a switch, and a switch is a layer 2 device. This switch uses MAC address in order to send and receive packets between two end devices. Let's come here. 172.16.0.3. The default gateway is 172.16.0.1, which is this port of the router. Whenever we are going to out of our network, so please use our default gateway, which is this one. Okay. Let's copy this one. Come to the other PC and paste it also in here. But this one is 2. Let's paste it in here. This one is 1. Okay, we are done with this. Let's come to the server. So I want it to be as HTTP or HTTPS as a web server. Let's come to the configuration. The default gateway is 1. Let's come to the port and say that this is 10. Subnet mask is default subnet mask. Okay, we are done with our server also. So okay dears, we have done nothing very special till yet. We have configured the network. We are going to configure the OSPF in these two routers, and after that we are going to configure the static NAT between this PC and the server. Then we will configure the path from this whole network to that network, and later on we will configure the dynamic NAT on this router. So here we may have bunch of IP addresses, so all of our private IP addresses would be dynamically mapped with this bunch of IP addresses and would be translated to any of these IP addresses and would be sent to the other network. Okay, so let's come to this router and configure the OSPF. Okay, now to configure the OSPF, we only need to write router OSPF with an ID, might be 1. Okay. Now our network 192.168.0.0 with its wildcard mask. So the wildcard mask is basically opposite of the subnet mask. So now let's find the wildcard mask in this way. Let's open the notepad for the class A, which is 255.255.255.0. Let's minus it with the full gateway, which is 255.255.255.250 full subnet mask. So we will get something like this: 0.0.0.255. So 255 minus 255, we will get a 0. 255 minus 255, we will again get a 0. And again the same. And in here we will get 255. So the wildcard mask is 0.0.0.255. Okay, incomplete. Oops, we forgot to mention the area. So area might be 0. Okay, now let's do the same for the other port. So the IP of the other port is 12.0.0.0, but the wildcard mask, let's find a little bit more mask of this one. So the default subnet mask for the class A IP address is this one. Opposite of this one, we will get a 0 in here and 255 in here. So we will get a 0 and 255. 0.255, 255, 255. Okay, so we are done for the OSPF in this router. Let's save it. Let's go to the other router. Okay, again, we are going to mention that router OSPF. Oops. Router OSPF1 network. So let's configure this network first. 172.16.0.0 with the opposite wildcard mask, so 0.0.255.255, and the area also, which is 0. Okay, and the other network, let me change the size of the screen. Okay, now in here we have 12.0.0.0. The wildcard mask for the 12 was the opposite, so something like this. Okay, I'm done with the OSPF also. So let's check that if this PC can ping this PC. Let's ping the default gateway first. So the default gateway is 192.168.0.1. Yes, we are reaching the default gateway. Now let's see if we are reaching the PC3 in this network. So it's something 172.16.0.3. Yes. So it means that the OSPF is doing right. So what problem is in this network? It looks like two different private networks, but no, actually this is our internet. This is a public IP address we are using in here. So we definitely need NAT. So let's come to this router and statically configure this PC to be statically NATed or mapped for this server. So whenever this PC wants to ping or send data or receive data from this server should understand that the source is not this PC. The source is this IP address, the public IP address 12. Okay, so let's come to this router. So it's a little bit easy. Okay. Okay. IP NAT. So IP NAT, sorry, inside source static, the IP address of the PC, which is 192.168.0.3, should be translated to 12.0.0.12. Okay, I think we're done. Now let's check. Let's we can check it by using the show IP NAT transaction, or we can use verify it by sending the data from this PC directly to the server and check the simulation. So first of all, let's check it in this way. Okay, let me fast forward it a little. The data is coming back and we received it. Let's just stop it in here. So let's see. First of all, the data came from the PC, then it went to the switch, then the router 0. In the router 0, let's see. So the source IP address is 192.168.0.3 and the destination is 172.60.0.10. Now it should translate it after in here to the the source IP address must be changed to 12. Let's see. We are seeing the same source IP address. I don't know why it is not translated. Let's check. IP NAT inside source static 192.168.0.3 to this IP address. Let me verify it. I think I have missed a very basic command. I didn't specify that which port is inside and which port is outside. So let's come to the interface geek 00 and I specified it that IP NAT inside. This is our inside network. Let's come back to the other interface, which is 01. Let me see. Yes, 01. I mean, specified that IP NAT outside. Now this should work. Let's check it again by sending a packet from this PC. Let's delete all the scenarios and check it again. Okay. So now in the router 0, the NAT should have worked. Okay. See, the source is 12.0.0.12 and the destination is 172.60.0.10. Because in here, this is our router, it did translate the source IP to public IP address. Let's see in here, the source IP was 192.168.0.3. It got translated later on to 12.0.0.12. And back when the server is responding to our request, the server changes the source and the destination. Let's see, the source is now the itself server and the destination IP is 12. The server don't know specifically our computer. The server knows this public IP address, and when the request came back to our router, which is in here, the router do it again. See, the destination IP in here is 12, which server is specified that, but in here, the router translated again the 12, which was a public IP address, back to our private IP address 192.168.0.3 and send it back to the PC. This one was example of a static NAT. Now let's go and jump to the path. So in the static NAT, we translated specifically one device with another device. In the pad, we will translate all the addresses in our private network. Let's suppose this is our home network. So we have a bunch of users, about 30-50 users. So all of their IP addresses should be translated to whatever this port's IP address is. So this port 01 port IP address is this one. So let's do it and practically show you. So for that, first of all, we need an access list. So to create an access list, we simply write access list. We name our access list, let's suppose that, and create a condition for it. Let's see, we have different conditions: deny, permit, remark. So we will permit which network. So in here we have to specify our network or our user. We will permit any user on this network. And now the wildcard mask 0.0.0.255. Okay, our access list is created, which later on we will use it for the path. Now let's jump to the path. So IP NAT inside source. Now our source is not a static in here. We have a list. Let's put a question mark. So we have a list option and a static option. So we previously worked with the static option. Now we are working with the list one in here. So list. The name of our list was 10 in here. So the name 10. Now the interface. The interface in here, which is our inside global interface, is gig 0/1, and after that overload because there are multiple users, so overload use their port numbers to differentiate them. Okay, now we are done with this one. Let's check it. Now this time let's send a packet with this PC to the server and also check it with the command in here. Okay, do we have any scenario? No. Okay, to this PC, simulation open. Okay, let me fast forward it. So in here, for the first time, switches have to broadcast a message in order to know their neighbors, in order to establish the neighbor connectivity and fill their MAC tables. So let's see, the packet is coming back and sent to our PC. Okay, let's stop it and see. So in here the packet got started, in here the switch 1 and the router 1. So let's open it. The source is 192.168.0. In here the source got translated to this one. So whatever PC we add in here with the network in this one 192.168.0.0, it would be translated with this public IP address if it sends data outside the network. So it was PAD. PAD is generally more used than any other kind of netting. So now let's come to the dynamic NAT. We will work the dynamic NAT on this side. So this is not a real world scenario, dears. We cannot route IPs, private IPs in here in the real world. And this PC can send data to this one, right? But in here there is no NATing. So this is not the real world. The real world, we have to have a NAT in here also. So let's do it with the dynamic netting. So the difference between the dynamic netting and the others are that in the dynamic net we can use multiple IPs. So we might have bunch of IP addresses in here. So let's suppose 12.00.13 till 12.00.20. So we have almost 7 IP addresses in here. So it doesn't matter for us that on which IP our packet will get translated. So in this scenario, we will use dynamic NAT. So we can use multiple private IP addresses in here, so they will be translated into one of these IP addresses from 13 till 20. The difference, one of the biggest difference is that we have to make a pool in here, and we have to make a pool from 13 till 20. Before that, let's continue here and let's see the um, transactions. Show IP NAT transaction. See, dears, this is inside global, as I said before, and this is the inside local, as I said before. So our data are being translated from this IP address to this IP address. And whenever we ping or send the data, the transaction should be shown in here. Let's check. So we are basically sending data to this PC. Now let's check. Come back in here. Can you see this? So this one was our IP address. We send the 4 packet with the command ping. It got translated to this IP address. These are the different port numbers, as I said, overload. So it differentiates them with this port number. Okay, dears. Now let's come back to this router and do the dynamic NATing. Okay, so as I said, we have to create a pool. So in order to create a pool, we will simply write IP NAT pool, the name of our pool, suppose my pool, and after that, the starting IP address, so 12.0.0.12, which is the first IP address, and we will continue. We can also put question marks in order to see what we need. Okay, and the IP address, so 12.0.0.20. As I said in here, that we will have from 13 till 20, and after that we would need net mask. So the net mask, okay, now we have to write the net. So the default subnet mask for this one is 255.0.0.0. Okay, the pool is created by the name of my pool. We have to create an access list also, so simply as we did before, access list suppose 20 permit 172.60.0.0 with the world port mask 0.0.255.255. So the access list is also created with the name of 20, and the pool is also created with the name of my pool. Now let's configure the dynamic NAT. In order to configure the dynamic NAT, as we did before, IP NAT inside So in here, source list 20. All right. And the pool, we have a pool. Let's put a question mark in here. We can have an interface and a pool all in here. So now we have a pool. So the name of our pool is my pool, and again overload, because we are allowing bunch of users in with the list 20. And the list 20, if we can see, we have these network IP addresses. So this can contain all the users who use this network. So okay, now let's enter and do right. Now let's check it, dears. We can, as I said, we can check it with the command show IP NAT transaction, and also we can create a scenario in here. Let's send the packet from this PC to this PC. Okay, now the packet is sent, and let's get the packet back also. The packet is also received. So starting from this PC, let's check it one by one. The source IP address is this one, and the destination IP addresses. Okay. Now let's see what this router 01 did. This router. Okay. In here, the 01 got the packet that the source IP address is this one and destination is this one. I think we have missed again this IP NAT source inside and IP NAT outside. Let's come to the interface gig01 IP NAT. This is inside. Let's come back to the gig00 IP NAT outside. Okay. Now let's delete this scenario and send it back from this PC to this PC. Okay, the packet is sent and the packet is received. Okay, DR SDP. Okay, let's delete the scenario because they are doing the broadcasting the switches. So our packet would be lost between all of all the broadcast packets. Okay, the data is being sent. This is the OSPF data. I don't know where our packet went. I think this one was our packet. Yes, this one was our packet. It went to here, and in here the translation should have been done now. Yes, so we can see that the source is this PC and the destination is this PC. Now the sources got changed to 12.00.12 and the destination is this one. Okay, this was one. This was all about different NATs, the static, dynamic, and pad. Hope you have enjoyed. Thank you.